Hello everyone, hope you all are doing well. This is the second lecture in this series of Java Interview Preparation Basics. In this lecture, we will study about the JVM memory parts and the various use cases of those parts of the memory. In the previous lecture, we studied about how class loaders loads the .class files, converts it to bytecode and loads that bytecode into the method area of the memory. So we will learn about what are the different memory areas, what are the use cases of those memory areas, and how Java manages the memory areas. Basically, what happens if one of those memory areas gets full, how Java ensures that even if the memory areas gets full, it keeps on running properly. We will study about each and every part. Firstly, let us begin with the method area, with which we have some prior experience because of the previous lecture. So as we studied in the previous lecture, that whenever you compile your Java code, the class loader loads the bytecodes of your program into this area of the memory. Other than that, all the class level information are loaded in this part of the memory. For example, the class name, what is the immediate parent that which the class extends to, what are the method names of this class, what is the code of the constructor, and some variable information, etc. So basically all the metadata related to each and every class is stored in the method area of the memory. Now method area is shared by all the threads of JVM. As you can simply think also that since all the class information is present in this part of the method area, in this part of the JVM memory, which is the method area, all the threads might need those metadata about the classes. So all the threads share this part of the memory. Now a basic question that should occur in your mind, you should be curious about knowing that what happens if this method area part of the memory gets full and there is a next allocation request that we need to store. What if the JVM makes a request that it needs to store some more data into the method area of the code and the method area doesn't have any space left? Do you know what will happen? An error will happen and JVM will throw out of memory exception. Now let us study about the stack area of the memory. So if you have coded in any programming language previously, if you have coded in your college time in C programming language, or even if you are new to the programming world, you must have heard about the recursion. So you know that for recursion, the call stack is always maintained in the stack area. That is, what is the order of the calling of the functions, that is always maintained in a stack. Similarly, stacks used in JVM is also more or less the same. So let us go about the details of how the stack method area is used. Now each JVM thread has a private JVM stack. Whenever a new thread is created in the JVM, and a new stack is also created which is directly assigned to that thread, which is used to store some data corresponding to that thread. Now these stack contain information about the sequence of method invocations. That is, whenever a thread is executing, the sequence in which it is calling different methods, that is stored in these stacks. For every method call, JVM pushes a frame in the stack which is then used to contain the method variables and the partial results. Now what do you mean by the partial result? Let's say that an execution of a method is going on, inside which you have some computation, and it contains storing the intermediate results into some variable which is defined inside the method. So those partial results are also stored in the stack area of memory. Heap area. Now heap area is one of the most important memory areas that you should be knowing as a potential Java programmer or as a professional Java programmer. This is the part of the area that you should know inside out, because this is the part of the area where most of the interview questions arise, and also you should be, most of the problems that arise in your code in terms of the performance or in terms of the resource usage arises because of this part of the memory area. Now heap area is created at the time of JVM startup. That is, whenever your Java process is started, heap area is allocated to your Java process. You can define how much heap area you want to be allocated to your Java process, and we will be having a separate detailed lecture about the heap area in Java. But for now, you can just know that heap area is created at the time of JVM startup. All objects are stored in the heap area. By all objects, I mean each and every object that you create during the runtime of your code is stored in the heap area. Even if you define integer a equals to 1, that a value is also stored in the heap area. Now the question must arise that because whenever you are running a program in production, generally the same build keeps on running for, let's say, 1 month, 2 months, 3 months. Now how come it is that after so much variable creation also the code doesn't fail? Because the heap area is limited. So what happens if the heap gets full? Behind the scene, Java makes sure that garbage collection goes on. By garbage collection, you must have heard about GC, the minor GC, the major GC. We will study about in details about garbage collection in a separate lecture also. So garbage collection continuously keeps clearing on the heap area so that new variables can be created and new objects can be created and stored in the heap. Even though if still your memory gets full, you will get an out of memory error, but generally you don't get an out of memory of heap error until or unless you have written really bad code. PC register, so this is one of the least important part of the JVM memory, but since we are covering each and every part, I will go through it. So this is the part of the memory where the JVM stores the program instructions. If you have studied in your computer COA architecture course, that program instructions are those that which will be the next code that needs to get executed, and all those things stored in the PC registers. So if you like this video, please subscribe to my channel, and thank you.